Hello there, Welcome back to the fifth session on architecture deep dive, Oracle architecture deep dive. Let me share the screen. Yeah, on the last session, we just completed the definitions. You can remember this was the last thing that we discussed. Smart flash cache, which acts as L2 cache for SGA and for the random access memory. Let's continue. Yeah, the next one is database mounted. Okay, so I just explained this one, just initiated the slide in the previous explanation. If you can remember, our explanation was based on this slide mainly. This is where we started. Then only we went to the definitions. And that was Oracle instant startup. That means we know Oracle startup process consists of 3 steps mainly: instant startup, mounted, and open. So we are at the very first stage. So after that only we went in to explain what is instance, and within that we have STA, we have background process, and what are the components. That's where we got the definitions. Remember, still the definitions. We haven't get into deep. It is actually very high level at the surface level. Little by little we need to go into details. So let's try to get in there. As the next explanation, we'll see what is happening after instant startup. What do you mean by mounting? So that is our next step. I think in the last lesson, I just showed you the command. And yeah, this is the command, but I think I have run the mount command, but let me just shut down again. Mount will right away. Mount means it will open the control file as well. But what we have been explaining was this command, startup no mount command. This what, right? Okay, let me run that once it's shut down. We can use the shut command instead of just type in full shutdown command. Okay, so we can just say startup no mount. So this will leave only the instance open. It won't get mount. That is what. So our next command is how do you mount it? So now we all know this, each and every output we are capable of having an explanation, basic one. The definition can be given, no. That is our whole purpose actually. If a Oracle command is given output on the database administration side, architectural point of view, we should be able to explain those. And I'm not touching the alert file as well, because now while these commands are happening, if I just keep the alert file open on the right hand side, then we just keep it open so that we can get more information actually. Then we should be able to explain those as well. I mean, little by little we are learning and getting matured with the architecture. So you should be able to explain most of those. So let it be like that. And okay, now the next thing is, now instant is started. So background process, memory structures, SGA, all the things are up now. So what is the next step? Alter database mount. I just typed it. They are not here, so they have to be here. So let's put it in proper order. Let's take that one forward here. Okay, now we are good. Alter database mount. Right? Or database mount. Now we are no mount. The next step is mounting. We ran tail minus F should be right. Tail minus F. Okay. Right. Now you can see the command completed all database mount. So what has happened actually? So let's get back to our slides. Now mounting means, now the instance is up. Mounting means having all of those components as it is. We have the STA, all the memory structures and background processes. Instance is up. Mounting means what? Control file will get open. So that is what mounting. Control file will get open. Database mounted. So as soon as mounted, it will open the control file and we can take a look at it. We can just type the command show parameter control. So that will show you the current control files. You can see I'm having unit1. There are two actually. That's the default. So one is on past recovery area as well. And we can just say this one as a describe $v control file. That's also there, and we can get the name from $v control file. Yeah. This is what I have two control files, not been multiplexed. We will learn later what is my multiplexing. This is all default. So these two control files both will get open because at any given time both are synced up, both are having the same information, control files. So this is default. So that is what happens. This will get open for read write actually, control files. Control files are very small in size, not around 20 MB. So it's not going to be so much size. And yeah, let's learn it later more detail. So that is the next step. So control file get open when you use the mount command, or if you right away type the startup command, instantly started then mounted means control file get open. Clear. Now let's go to the other one. What's going to happen? Control file is open, and the next one is what was the next? Our next step. This is what's going to happen. Data files, redo log files will get open. That is what. That is what you mean by. So now we have all database files: data file, control file, redo log file. Because when somebody asks what are the Oracle files belongs to Oracle database, files belongs to Oracle database, mainly three types: data file, control file, log file. So that is mean by what? Database open, database opened. So that's the last step in the database opening process. We can just type alt database open. That is what. On the right hand side, you can see it is there are a lot of information coming out. So actually what's happening in the control file, what are the file names of the DBF files? Not only DBF files, no. You saw that we had redo files as well. So control file has those information. Control file is aware what are the data files, what are the locations, what are the names, sizes, and everything, current status, everything. And what are the log files, where are the locations, sizes. So what's going to happen? As soon as Oracle mounted, it control file get open. Then as per the information given in the control file, Oracle will continue to open the database. That means it will continue to open the rest of the old data files as well as the log files. That's what's going to happen. So now in our database, I think if you see the alert log output, and this is about patch information, and you can see it is giving information about the open process. I think undo table space and all, yeah, those are compulsory ones. System table space, yeah. Anyway, the data files belongs to those will get open. And if you want to see the data files, you can say select command, select name from $v data file. Yeah. So these are the DBF files. Of course, it's a container database I'm using. That's okay, right? So that's why I have the pluggable databases as well, but pluggable DBF files as well. But anyway, it doesn't matter. So DBF files, these things will get open. And if I want to see the log files, describe $v log file, you can say select member from $v log file. So that will give my log file information. So this I have 3 log files. So these things now being open. So that is what I mean by database is open, select status $v instance. Now database is open. Earlier, if I check the status, when it is mounted, it will say mounted. While the instance is only running, it will say started. So there we have different status. If only the instance is running, the status will be started. If it is mounted, it will say mounted. Now it is open, it will say open. Fine. Now we have a bit of clear understanding about the 3 steps and what's happening behind. Very basically, at a high level, now you know. Okay, so now let's proceed to the next step. Yeah, let's talk about another concept called granule. Granule. The granule. What is a granule? You can see the SGA comprises several memory components which are pools of memory used to satisfy a particular class of memory allocation requests. We know that. In SGA, we have different memory database, buffer cache, shared pool, redo, Java pool, large pool. Now the issue is we have given a particular size. No, initially we can give a size, and of course these memory structures can be managed automatically and manually. There are techniques like automatic memory management, manual memory management. There are techniques. Under manual, we can give sizes. Under automatic, there is a different way. We have memory max size, SGA target, and those stuff. SGA target comes under automatic shared memory management. Memory max comes under automatic memory management. So whatever way, we can either leave all these automatic memory component like database buffer cache, shared pool, Java pool, large pool under 0. We can assign value equal 0 for memory structures. Then what will happen? Enable automatic memory management. Then Oracle will automatically manage those. But ultimately, these should have some sizes, no? And it has to start from somewhere. So how it starts, that is where the granule is coming now. The smallest memory chunks which are going to get allocated for these memory structures, that is what known as a granule. You can see all SGA components allocate and deallocate space in units of granules. That is what granule is. All SGA components allocate and deallocate space in units of granules. Oracle database tracks SGA memory use in internal numbers of granules for each SGA component. That's what. But there's an exception here, the redo log buffer. Redo log buffer is an exception which has a different memory allocation technique. We'll talk that in more detail later. Other than that, or especially the automatic memory allocation, you can see large pool, Java pool, DB buffer cache, shared pool, all are allocating memory in terms of granules. Okay, so then comes what is the size of the granule? Because it starts from a granule. Okay, shared pool, it will start allocating granules. Then how much? That is what. So granule is going to be the smallest memory chunk, the smallest memory allocation unit in SGA. Okay, so I mean it's true for PG as well. Let's talk that one later. The memory for dynamic components in the SGA is allocated unit of granules. Dynamic means that's what I mentioned, automatic memory management. Dynamic components, automatic memory management. So those are definitely allocated in terms of granules. So concept of granule is very important. And the granule size is based on SGA max size initialization parameter. So that is the key here. We can set the size for SGA max size. What is the maximum size for SGA? SGA max size. There's a value we can give for SGA max size parameter. We will learn it more detail later. On the memory management, we are going to learn those things. So if you give the SGA max size a particular value, so that will be a condition to determine how much the granule size is. You can take a look at it more detail. Now here we have the granule sizes. We can see the granule sizes. So if the SGA max size parameter is less than or equal 1 gigabyte, then Oracle will automatically select the granule size as 4 MB. Greater than 1 GB and less than or equal to 8 GB SGA max size, then 16 MB of granule size. For example, if it is a particular, let's say, large SGA due to a heavy workload, so then we are having 32 GB and 64 GB as the upper limit. Then we have the larger granule size, 128 MB. So the automatic memory components will start with this size as minimum, 128 MB. So likewise, the granule size will vary depending on the SGA max size parameter. Of course, earlier, I think till 11G, we had only two granular sizes, 4 MB and 16 MB. But now, this starting from 12.2 and onwards, we have multiple granular sizes. So you need to have the knowledge on that. But anyway, you got the idea behind it. If you want to take a look at in practical, now let's take a look at in my database. Okay, let me just go up. I think there was a command which I have. Yeah, so this is what so is GA max size. Here you can take a look at it. Let me just, yeah, these commands. $B from $, SGA info. But first of all, let's take a look at our SGA size. This current database, what is the SGA size? So we can say show parameter SGA max. So in my case, I have 3 GB, right? So 3 GB. So that falls under which category? This category, no, greater than 1 GB, less than 8 GB, not the smallest here, this one, second category. So my granule size should be 16 MB, right? We can check it whether it's true or false. We can paste that command. Select bytes from VWSGA info where name like granular size. So this will do it. So you can see it is 16 MB. This is in bytes. So you can see K and 16. So that is how. Since I have more than 1 GB and less than 4 GB, so it has selected 16 MB granular size. So that is how. If I increase my SGA to greater than 8 GB, then what's going to be? It will come to the 32 GB range, greater than 8 GB, less than 16 GB. Likewise. Okay. And further, if you want to get more details about this granule, actually, this is from my support. So they are also explaining certain things on granule. So you can see this document ID, I think, yeah, 947.152.1, and this there, what is a granule and all. What is a memory granule? I think now it is almost clear because we have learned, I have explained it. You can see when a database instance start up, the amount of memory allocates is determined by allocations requested by a parameter file, integer file. Yeah, that is memory structures. We can parameterize. No, we can give the values for the memory. What is the size for DB buffer cache? What is the size for SHA-4? Those are in parameter file. The memory is allocated in units called granules. So that's what. All memory pool sizes will be allocated multiple of granule sizes. So it is clear, and this is the same thing that I have explained. But here they talk about the new parameter, which is introduced in 12C, memory max target. So if you just read that part, how the granule size is determined? The granule size is determined based on the amount of memory requested at the instant startup. If the based on SGA max size, it is based on SGA max size. If memory target is specified, then SGA max size defaults to memory max target. For this purpose, the sizing of the granule, yeah, the sizing, yeah, for the purpose of sizing the granule. So once set, the granule size does not change. So this is a little bit of important one because memory max target, if we have used it, memory max target, we are using automatic memory management. SGA max size, SGA target, not SGA max size. That's okay. Yeah. No, let's not get confused. So let's try to understand what is told here. Otherwise, automatic memory management, memory max target, memory target, SGA target, those all are different parameters. So what is said here, it is based on SGA max size, almost explained. If memory max target, we can set this one instead of setting SGA max target, we can set a different parameter starting from 12C memory max target, because this covers the PGA, SGA both together, memory max target. And if that is specified, then SGA max default to memory max target. That's what they are telling. So That is only for the purpose of setting the granule size. That is what. Okay. Then we have a few exceptions as well. On 12.2, 18C, 19C, it is based on memory target IMCs. We have in memory. So these are extra details I am just telling, but might be important in production environment. Because if somebody had defined in memory, I think we have learned our in memory. If I go back, our STA, we had in memory, right? I think if you can remember this one. In memory area. So if somebody had defined this parameter in our STA, so then what this my support is telling, the behavior will get changed a bit about this granule, because it will, I mean, first of all, in-memory component will be reduced from the total STA size. So these are the memory granule sizes given. So this document explains that C granule sizing for 12.2, 18C and 19C, because there's a little bit of change on 19C, especially 19C. So this document will explain that one. And it is clearly explaining about the impact of this in-memory parameter in 19C. So you can see this is in prior to 18C, prior to 18.9, and likewise in 19C they are explaining like this. This is yeah, it is here clearly. This is in 19C, so this is what they're telling. Let's closely look at it. So what they are telling here, 18C, prior to 18.9, the version, this is after patching. The startup command, what will happen, there was a bug, so that's why it is not correctly telling the STA size, not the STA size, the granular size. But what they're telling is, in 19C, they have fixed the issue. So the correct granular size is being reflected. So that is what they are telling now. For example, what they are telling here, you can see what is this SGA max size here. What is the total value of SGA? You can see it is total SGA size 2 GB, no? So having 2 GB, we can't have 16 name, right? So what is our formula? Our formula said, yeah, less than 1 GB, it is 4 MB. Yeah, correct, no? Less than 1 GB, it is 4 MB. Between 1 to 8, it is 16 MB. And here, what they are trying to say, what is this value? This is in bytes, right? So this is in bytes, no? And the R value is 16 MB. And this is, and after that, in 19C, you can see the same output is there in 19C. This is 18C, right? Same output. The granule size is 4 MB. Now, this is in bytes. If you convert, this is going to be bytes, kilobytes, MBs, and gigabyte. It's going to be less than 1 GB. You convert it. So the less than 1 GB means correct value should be 4 MB, no? 4 MB. But here in 18C, it shows as 16 MB. But this is in 19C, it shows the correct value. So this is a bug actually. They are telling the reason as well, because of the in-memory. In-memory components should be reduced. So that's why. You can take a look at this one. I don't need to explain this one. Actually, this is 2 GB, right? Yeah, this is 2 GB. But PixSC, and let's see this one. Here we have in-memory. There's in-memory allocation here. You can see there is in-memory. Now, the specific point here is we have in 19C, this one, there is 1 GB given for in-memory. And here you don't have in-memory. So if you consider this one, it is not going to be less than 1 GB. So this is 2 GB, right? If you correct it, nearly 2 GB. Yeah, this is going to be KB, this is going to be MB and GB. Yeah, it comes to 2 GB. So this is 16 GB is correct then, but yeah, 16 GB no. Between 1 GB to 8 GB, it is 16 MB. 16 MB is correct. But here in 19C, even though the same SGA max size is there, in 19C, they are giving 4 MB. That's the problem. The reason is here we have given the in-memory being allocated, where it is not given here. So what's going to happen when the in-memory is in use? Oracle will reduce that part from the total SGA. That means this value minus this value. Then that will be taken as the SGA max size. So definitely it's going to be less than 1 gigabyte then. Right? So less than 1 gigabyte means it falls under first category. So that is the way. Just try to understand that. So then it says granule size is 4 MB. Otherwise, you may wonder why this one also SGA max size is 2 and this one nearly 2 gigabyte and this one also 2 gigabyte. So why different granule sizes? The reason is that in 19C, this in-memory parameter works correctly, but in 18C, if you introduce in-memory parameter, there's a bug. That's why this, I think it is been explained here. This was investigated and unpublished the bugs, right? So anyway, this is for just for information. In 19C, use memory target, SGA target, subtract in memory. This is what I mentioned. In memory component, it will subtract that part. Okay, so just to give you an idea about some extra thing on these granule sizes, but I think you got the concept what is granule and all. Fine. So now we are good there. Okay, so as per the explanation, now we got the idea about open and this mounting and all. Now, in our explanation, still we are touching the high-level components, not in detail. So we have a few more things to touch like that, because now we got the idea about, this is our very first third slide. Now we got the idea about HGA. Now we know in detail definitions for the HGA, not the component interaction. Now we are going to see PGA components and UGA components and what are the software codes as well. And further about server process as well. Now we got to know background process and server process and client process. High level we are going to take a look at. So having done those things, after that only we are going to get into deep dive architecture. Now this is very high level still. No? Deep dive architecture, how these components are working. We are going to work through with SQL commands. When a DML command happens, what's going to happen? When a select command, what's going to happen? Like this. And let's slowly we will get there. Fine. I think I'll stop here with this slide, and I'll meet you in the next session. So that's going to be the 6th session. All right. I meet you soon. Have a great time. Bye bye.